Hello, guys. It is the second part about blockchain and also about structure of blockchain. A blockchain is a decentralized, distributed, and oftentimes public digital ledger consisting of records called blocks that are used to record transactions across many computers so that any invalid block cannot be altered retroactively without the alteration of the subsequent block. This allows the participants to verify and audit transactions independently and relatively inexpensively. A blockchain database is managed autonomously using a peer-to-peer network and a distributed time-stamping server. They are attained by mass collaboration powered by collective self-interest. Such a design facilitates a robust foreflow where participants' uncertainty regarding database security is marginal. The use of blockchain removes the characteristic of infinity reproducibility from a digital asset. It confirms that each unit of value was transferred only once, solving the long-standing problem of double spending. A blockchain has been distributed as a value exchange protocol. A blockchain can mainly title right because, when properly set up to detail the exchange agreement, it provides a record that compels offer and acceptance. Logically, a blockchain can be seen as consisting of several layers: infrastructure, that hardware, networking, which node discovery, information propagation and verification. Consensus, this is proof of work and proof of stake. Data, that blocks and transaction. And the last is application. Smart contrast, decentralized application if applicable only. Blocks hold batches of valid transactions that are hashed and encoded into a Merkle tree. I think you know what is that. And each block includes the cryptography hash of the prior blocks in the blockchain, linking the two. The linking blocks form a chain. This iterative process confirms the integrity of the previous block all the way back to intentional block, which is known as a genesis block. To assure the integrity of a block and data contained in it, the block is usually digitally signed. Sometimes separate blocks can be produced concurrently, creating temporary work in addition to a secure hash-based history. Any blockchain has a specific algorithm for scoring different versions of the history so that one with the highest score can be selected over others. Blocks not selected for inclusion in the chain are called orphan blocks. Peers supporting the database have different versions of the history from time to time. They keep only the highest scoring version of the database known to them. Whenever a peer receives a high scoring version, usually the old version with a single new block added, they extend or overwrite their own database and retransmit the improvement to their peers. There is never an absolute guarantee that any particular entry will remain in the best version of history forever. Blockchains are typically built to add the score of new blocks onto old blocks and are given incentives to extend with new blocks rather than overwrite old blocks. Therefore, the probability of an entry becoming superseded decreases exponentially as more blocks are built on top of it, eventually becoming very low. For example, Bitcoin uses a proof of work system where the chain with the most cumulative proof of work is considered the valid one by the network. The number of methods that can be used to demonstrate a sufficient level of computation. Within a blockchain, the computation is carried out redundantly rather than in the traditional segregated and parallel manner. The block time is average time it takes for the network to generate one extra block in the blockchain. Some blockchains create a new block as frequently as every 5 seconds. By the time of block completion, the included database becomes verifiable in cryptocurrency. This is practically when the transaction takes place, so a shorter block time means faster transaction. The block time for Ethereum is set to between 15 and 15 seconds, while for Bitcoin is an average 10 minutes. A hard fork is a rule change such that software welding according to the old rules will see the blocks produced according to the new rules as invalid. In case of a hard fork, all nodes meant to work in accordance with the new rules need to upgrade their software. If one group of nodes continues to use the old software while the other nodes uses the new software, a permanent split can occur. For example, Ethereum was hard forked in 2016 to make whole the investors in the DAO, which had been hacked by exposing a vulnerability is the code. In case the fork resulted is a split creating Ethereum and Ethereum Classic chains. In 2014, the NXT community was asked to consider a hard fork that would have led to a rollback of the blockchain. Records mitigate the effects of theft of 50 million NXT from a major cryptocurrency exchange. The hard fork proposal was rejected and some of the funds were recovered after negotiation and ransom payment. Alternatively, to prevent a permanent split, a majority of nodes using the new software may return to the old rules, as was the case of Bitcoin split on 12 March 2013. Okay guys, it's all. Thank you for watching. Have a good day.